Hello, this is Dr. S. This is for pre-calculus. This is for Tuesday, March 17th, I guess it is. This session will be devoted to finding the area of triangles. Now, yesterday I gave you an exercise on finding areas. 1/2 base times height is the formula, and you did a few of them. And there's an exercise I'd like you to do, but before getting into it, I want to explain what the new formula is going to be. Now, what you see here is a triangle that I've drawn on graph paper. I will send you some graph paper in a file tomorrow if you don't have any, but you must have a ruler, which I think most of you should have. Now, let me explain what we're going to do. You see a picture here of a triangle that I made using a ruler on graph paper. It has 3 sides. Now, how did I get the numbers that represent the lengths of the sides? They were actually measured by the ruler. So I've got a center of 6.5. That's the height. One side is 3.5. Another side is 6.3125. And I have 6.75, and I've labeled the vertices. And you can see below that I have calculated the standard area formula, 1/2 base times height. I've taken my measured numbers of 1/2 times 3.5 times 6.5, and I get a number of around 11.375. Okay, now there's a new formula that we're going to learn about for finding the area. It's a little bit more complicated, but it is very general in case you don't have the measurements of the height. It's called Heron's formula. That's Heron's formula. And the input that we need for Heron's formula is small a, small b, small c. I think most of you know what I mean when I say that. That's the side lengths, and we only need the side lengths. So I'm just going to go through the mechanics of the formula and show you the calculation. What we first do is take the sum of the sides and divide it by 2. That's called the semi-perimeter. Now in this case, my 3 side lengths are 3.5, 6.3125, and 6.75. When I add them together and divide by 2, I get 8.28125. Now here is the interesting formula called Heron's formula that's used to calculate the area of a triangle. Now I'm calling this number S for semi-perimeter. The usual perimeter formula is the sum of the sides, but in this case I'm dividing by 2. So the area is given by the square root of S times S minus A times S minus B times S minus C. So I ran through the calculation here. S minus A turns out to be this number, 4.78 approximately. S minus B is 1.9869 approximately. S minus C is 1.53 approximately. Now when I do the calculation, namely put all of these numbers into the radical and take the square root, I get as an area 10.9254. Compare that to the number that I got using the standard 1/2 base times height. I got 11.375. Now given that I'm doing this by hand, there's inaccuracy in my measurements and so forth. It's not a bad approximation. 11.375 versus 10.925. So your exercise is, I'm going to give you graph paper. I would like you to create your own triangle in the way that I've done here. Well, not exactly the same way. Create any kind of triangle that you want by taking a grid point, picking another grid point, and then picking another grid point, connecting these lines, these 3 lines for the perimeter of the triangle, measuring them, writing down the numbers, and then picking one of the vertices and look at the side opposite that vertex and get roughly the midpoint. That could be one of the reasons that I had inaccuracy. I may have been off on the midpoint. So try to get the midpoint of the base. You get your height, measure the height, measure the base, multiply the two, take 1/2, get an area number. Then I would like you to take your chosen triangle, go to Heron's formula, calculate S minus A, S minus B, S minus C, put them under the radical sign, take the radical, see what kind of number you get. Compare that number, in my case, 10.9254, to your 1/2 base times height area formula, and see how close you get. You can do it several times if you want. I think this is a really interesting exercise and can show you the relationship between the standard area formula and Heron's formula. So this will be sent out to you tomorrow. Have a good curfew. Good night.